Hey everyone, it's been a while since my last Minecraft clone video and I've made a ton of improvements I'm excited to share. Today I'll walk you through some optimizations like vertex packing and a handful of new features. So let's dive in. Back when I started, the goal was just to get something up and running, and as a result the codebase became a tangle of prototypes and spaghetti code. So in this video I'm going to mainly focus on performance and refactoring. First, let's talk about the camera. I had this annoying bug where the view would slowly drift to the right even when the mouse was still. Rather than hunting down the bug in the camera class, I decided to rewrite most of it from scratch. While I was at it, I moved the spawn position above ground and pulled out the bounding box indicator into its own class and improved it. Now, not only is the camera stable, but highlighting the targeted block is clearer. There's both a box around it and a color highlight. Next up was terrain generation. You'll notice the world looks more interesting now, with sand appearing both underwater and along the shoreline, plus rolling hills scattered throughout. That's thanks to applying 3 different noise layers: base terrain, shoreline sand, and a hill overlay for extra variety. Under the hood, I also simplified the chunk class by removing subchunks, because infinite height chunks were overkill for this project. While refactoring, I fixed multi-threading issues that sometimes caused exceptions on exit and visual artifacts during chunk creation. Now chunk generation runs smoothly without hiccups even while I'm flying at full speed. Speaking of cleanup, the block rendering class was a disaster. I rewrote it from the ground up for clarity and maintainability. Performance has slightly improved too. Although the difference isn't drastic, clean code matters more for the long-term development. At this point in time, I stumbled upon a YouTube video about writing shaders in Shader Toy. This inspired me to start building my own shader, the same one you're seeing right now. I'm going to leave a link in the description if you want to check it out and play around with it. With that shader experience, I revamped the pixel shader for block rendering, adding a subtle vignette effect to each block. It's not full ambient occlusion yet, but the blocks have a bit more depth. Ambient occlusion might come in a future update. And towards the end, I'll show you one more shader I think turned out pretty cool. One lingering issue from the previous version was sorting transparent blocks. While chunks were already being drawn in order based on distance from the player, that didn't solve the issue within the chunks themselves. Transparent quads could still render in the wrong order relative to one another. This meant some transparent blocks would incorrectly cover others, breaking the visual accuracy. To fix this, I introduced a separate list of transparent quads and further optimized the sorting by doing these 2 things. First, I only sort quads within a 4 chunk diameter around the player, drastically cutting down the count of chunks that need transparent block sorting. And second, I only resort when transparent blocks change or the camera moves more than 1 block. No need to sort on every draw call. These tweaks keep the performance impacts to a minimum. Now for the long-awaited vertex packing, an optimization that's especially helpful on lower-end GPUs. This one was a major headache. Ideally, I'd use vertex pooling for more flexibility, but monogame restricts me to HLSL version 3.0, which doesn't support bitwise operators, proper integer types, or anything similar to SSBOs. That forced me to get creative while using just floats. Originally, each block vertex used a struct with 6 floats. A vector 3 for position, a vector 2 for UVs, and 1 float for light. That's 24 bytes per vertex. With vertex packing, I compressed all that down in just 2 floats, 8 bytes total. To make this work, I had to get creative with how I store vertex data. Instead of sending full world position for each vertex, I send the chunk's world position once per draw call. Then each vertex only needs to store its position relative to that chunk. Relative x and z values are always between 0 and 15, so those can each fit in just 4 bits. The y value ranges from 0 to 255, which fits in 8 bits. That's 16 bits just for position. Next, I pack in lighting data. The light level ranges from 0 to 15, which takes another 4 bits. Then there's the corner ID of the vertex, which identifies the corner of the face we're rendering. And since there are only 8 possibilities, that fits in 3 bits. On top of that, I need to know what texture to use and what face of the block we're rendering. I'm using a 16x16 texture atlas, which means we need 8 bits to index up to 256 textures. We also need the face index, one of the 6 sides of the cube, which fits into 3 bits. Altogether, this data adds up to 34 bits. 4 bits for X, 4 for Z, 8 for Y, 4 for light level, 8 for texture index, and 3 each for corner ID and face index. We know that 32-bit float is made up of 3 parts. 1 bit for the sign, 8 bits for the exponent, and 23 bits for the mantissa. The mantissa stores the actual digits of the number, representing its precision. Because only 23 bits are available for the mantissa, that means the float can reliably store about 23 bits of each integer data before precision starts to degrade. Bits beyond this can be lost or rounded off, leading to inaccuracies. So when packing multiple pieces of data into a single float, we have to keep the total number of bits within 23 to ensure the value can be reconstructed accurately without losing detail. This is important for the next part. We're going to use two floats to store our data as follows. The first float stores the packed position, light level and corner ID, coming in at 23 bits total. The second float handles the face index and texture index, which together take up 11 bits. Both are well within the precision limit for floats, and in the future I can use more bits for the texture index if I want to have more block textures available, or maybe store information that I can use for ambient occlusion. This method reduces each vertex from 24 bytes to just 8. It's more work to unpack everything in the shader, but the memory savings are huge, especially for lower end systems where the bandwidth and memory size are limiting factors. I'm going to be honest, after wrapping everything up, I haven't really noticed an improvement in FPS on my computer. But I did notice an improvement in memory usage, as you can see, which basically halved for both the working set and the private memory. And as a fun experiment, I tested all of this on an i7 24p laptop with integrated graphics on 60% battery. And I was still getting between 150 and 250 FPS, which is honestly kind of wild. One caveat with this optimization is that we lost the lower water level visual that we had before. Now water blocks are at the same level as other regular blocks, but this is a thing I'm going to leave for the next update. Finally, I added the water shader and an underwater surface effect, similar to Minecraft. The shader includes a subtle fog effect that makes the bottom of the screen look darker and more bluish, which in my opinion adds a sense of depth. There's also wave distortion that moves across the screen, giving the impression of looking through shifting water. Because I didn't want to sacrifice the backface culling to show the water's surface from underneath, I just doubled the top faces of the water blocks that have an air block above them, flipping them in the process so they are visible from the opposite direction. It's a small detail which I totally didn't make just because I wanted an excuse to mess around with shaders, but to my credit, it really adds to the immersion when you dive below the surface. Reminder that all of the code is open source and you can find it on my GitHub. I will leave a link to the repository in the description. I hope this will help anyone who wants to learn more about making games with monogame or creating their own voxel engine. You're also free to contribute or fork the repository if you want. There's still a lot of work to do on this project, and in the next update, whenever that will be, I want to address world generation and more basic features of Minecraft. And that's it for today's update. If you enjoyed the video, please hit like and subscribe, and maybe join my Discord server so you can stay up to date or talk about game development and programming with like-minded people. Thanks for watching, and see ya!